Module 2. Developing Number Sense. Teaching mathematics to very young children involves providing high-quality number activities using a developmental approach. It is essential to design activities that are engaging and appropriate for their developmental stages. A developmental approach recognizes that children acquire mathematical understanding gradually and through concrete experiences. For instance, using manipulatives like counting blocks, number lines, and visual aids can help children grasp the concept of numbers and their relationships. These activities should be designed to cater to the diverse needs of learners, ensuring that each child can build a solid foundation in number sense. Developing children's skills in generalizing problem structures with additive situations is another crucial aspect. This involves teaching children how to solve problems that include joining, separating, part-part whole, and comparison situations where the unknown can be in any position. For example, a part-part whole problem might involve finding out how many apples and oranges are there altogether if there are 3 apples and 5 oranges. By using such practical examples, children can better understand how addition works in different contexts. This skill is fundamental as it helps children see the broader application of addition beyond simple arithmetic. Comparing the approaches to developing fact fluency is essential, especially when considering the 3-phase strategy-based process. This process includes understanding the problem, applying a strategy, and reflecting on the solution. It helps children not just to memorize facts, but to understand and internalize them. For example, when teaching addition facts, teachers can encourage students to use strategies like counting on, making 10, or using doubles. These strategies make learning facts more meaningful and help students develop a deeper understanding of numbers and their relations. Interpreting the pre-base 10 understandings based on a count-by-ones approach to quantity is another critical component. Before children understand the base 10 system, they often rely on counting by ones. Activities that involve counting objects, making groups, and comparing quantities help children transition from this concrete understanding to more abstract concepts. For instance, children can be given a set of blocks and asked to count them first individually and then in groups of 10. This exercise helps them see how numbers can be grouped and how these groups form the basis of the base 10 system. The connection standard of the 5 process standards from Principles and Standards for School Mathematics reflects the importance of giving students opportunities to see how various mathematical ideas relate to one another and to a variety of real-life experiences. This approach helps students make connections between different areas of mathematics and see the relevance of mathematics in their everyday lives. For example, understanding the relationship between addition and subtraction can help students solve real-life problems more effectively. The thinking behind the creation of the Common Core Standards for School Mathematics is similar to the NCTTM Principle and Standards for School Mathematics. Both sets of standards are comprised of learning progressions that can inform instruction. These progressions guide teachers in understanding what came before and what to expect next, ensuring that instruction is coherent and builds on previous knowledge. This continuity is crucial for developing a strong mathematical foundation in students. Making connections among mathematical relationships improves student conceptual understanding. A key tenet of this belief is that teachers should scaffold new content through the use of tools and peer assistance. For example, when introducing the concept of multiplication, teachers can use visual aids like arrays and number lines to help students see the relationship between repeated addition and multiplication. Peer assistance, such as working in pairs or groups, can also facilitate learning as students explain concepts to each other and learn collaboratively. Teaching for mathematical proficiency requires students to memorize less, allows them to make connections to new concepts more easily, and increases their enjoyment and attitudes towards mathematics. Rather than focusing solely on rote memorization, teaching for proficiency involves engaging students in meaningful mathematical tasks that require them to think critically and solve problems. This approach not only enhances their understanding, but also makes learning mathematics more enjoyable and relevant. Selecting, designing, or adapting a worthwhile task requires teachers to ask if the task has the potential for students to demonstrate mathematical practices. Worthwhile tasks are those that engage students in deep thinking, require them to make connections between concepts, and apply their knowledge to solve problems. For example, a task that involves solving a real-world problem, such as planning a school event with a budget, can help students apply mathematical concepts in a practical context. Differentiation of instruction in mathematics lessons is needed to support and challenge the learning for all students. One example of a differentiating process is identifying what thinking will engage students in the mathematical content. Differentiation can involve providing different levels of support, offering varied tasks that cater to different learning styles, and using flexible grouping to ensure that all students are appropriately challenged and supported. For instance, while some students might work on basic addition facts, others might be exploring more complex problems involving multiple steps. Research-based recommendations for high-quality learning activities in the first 6 years of life include enhancing children's natural interest in mathematics, using formal and informal experiences, and assessing children's mathematical knowledge. These recommendations emphasize the importance of creating a rich mathematical environment where children can explore and discover mathematical concepts through play and structured activities. For example, activities like sorting objects, playing with shapes, and exploring patterns can help young children develop a strong foundation in mathematics. Developing an understanding of the concept of zero is important, especially its role in the base 10 number system. Zero is not just a placeholder. It represents the absence of a quantity and plays a crucial role in our number system. Activities that involve counting, adding, and subtracting with zero can help children understand its significance. For instance, using a number line to show what happens when you add or subtract zero can make this concept clearer. Reading and writing numerals is similar to teaching children the alphabet and reading. Developmentally inappropriate practices for early learners, such as worksheets with numbers to trace, should be avoided. Instead, children should be encouraged to engage with numbers in meaningful ways, such as through games, puzzles, and hands-on activities that allow them to explore numerals in context. While developing students' understanding of the relationships for numbers 10 through 20, it is important to remember that even though students experience numbers up to 20 regularly in real life, they may not automatically extend the relationships they learned for numbers 1 to 10 to bigger numbers. These relationships are just as important as the ones involving numbers 1 to 10. And children should learn that there is a set of 10 involved in any number between 10 and 20. Activities like grouping objects into tens and ones can help children understand this concept. Graphs clearly exhibit comparisons between numbers. Asking questions like, "How much is the difference between apples and oranges?" requires a comparison response and helps students develop their understanding of numerical relationships. Using contextual problems as a primary teaching tool is important because children construct richer understandings of the operations. Contextual problems provide relevance to students' lives, making the mathematical concepts more meaningful and easier to understand. A person who has mastered basic facts has obtained a set of essential understandings and progressed through a set of stages so that they just know the answers to certain basic fact problems. Mastery of basic facts involves not just memorization, but also the ability to apply these facts in different contexts and to understand the underlying concepts. For example, knowing that 5 plus 5 equals 10 is important, but understanding why this is true and being able to apply this knowledge in different situations is what constitutes true mastery. Despite the fact that many learners in the past learned basic facts from memorization, there is strong evidence that this may not be the most effective strategy. Memorization involves many facts and is an inefficient process. When facts are memorized, students are less likely to check their work, and counting by ones is inefficient and delays the development of efficient reasoning strategies. Instead, teaching strategies that promote understanding and application, such as using story problems, can provide a valuable context to help students apply reasoning strategies for computation. Story problems provide relevance to students' lives, make them better problem solvers, and offer practice with basic facts in a meaningful context. Effective reasoning strategies to help students learn difficult facts include doubling, close facts, and doubling and one more set. These strategies help students develop a deeper understanding of number relationships and make it easier for them to recall facts. For example, knowing that 6 plus 6 equals 12 can help a student understand that 6 plus 7 is just one more than 6 plus 6, making it easier to remember that 6 plus 7 equals 13. Supporting older students who still struggle with basic facts can be done through steps such as providing hope and building in success, inventorying known and unknown facts, and providing engaging activities. It is important to build confidence in these students by showing them that they can succeed and by providing opportunities for them to experience success. Engaging activities that are enjoyable and relevant can also help motivate these students to practice and improve their skills. Recommendations that can support students' ability to quickly recall basic facts include involving families, using technology, and encouraging students to self-monitor. Family involvement can provide additional support and practice at home, while technology can offer interactive and engaging ways for students to practice. Self-monitoring encourages students to take responsibility for their learning and to track their progress. Examples of proportional base 10 models include counters and cups, cubes, and strips and squares. These models help students visualize and understand the base 10 number system by providing concrete representations of abstract concepts. Activities that connect base 10 concepts with oral number names, such as using arrays to cover rows and columns, and asking students to identify the number name, lying out base 10 models, and asking students to tell you how many tens and ones, and using a chain of paper links to estimate tens and ones, can help students make these connections. Providing opportunities for students to see and make connections to numbers in the real world is essential for developing their number sense. Examples that would engage students with large benchmark numbers include measurements and numbers discovered on a field trip, the number of milk cartons sold in a week at an elementary school, and the measurement of students' height in second grade. These real-world examples help students understand the relevance and application of mathematical concepts in their everyday lives. In conclusion, developing number sense in young children involves a combination of high-quality activities, a developmental approach, and strategies that promote understanding and application. By providing engaging and meaningful experiences, teachers can help students build a strong foundation in mathematics that will support their learning throughout their educational journey. Addressing the questions attached to this unit within the flow of the essay highlights the importance of these concepts and reinforces the need for a comprehensive and thoughtful approach to teaching mathematics in the early years.